Hi, I'm Steve DiPaolo. I'm your professor for immersive environments, iat445, which is about VR, AR, and MR, which we'll just start calling XR, and I'll just refer to what we're doing in this class, and even the name of the class is XR. You see a whole bunch of versions of this on the screen, most from work that we're doing here at Simon Fraser University. We're quite world renowned for some of the research we're doing in the space. And in fact, students from this very class working on that research and then being at some major companies doing it. So we'll talk more about that. What is this thing called XR? Well, you've probably heard of VR, virtual reality, which immerses you fully in an artificial digital environment. AR is augmented reality, where you're still seeing part of the regular world, and you're seeing an overlay of these virtual objects. You can do that with your phone or an iPad or in other ways, and I'll show that in a second. And this conglomerate is mixed reality, which is not only overlays, but anchors like virtual objects in the real world and allows you to interact with them. So imagine you actually have objects on your desk. Some of them are real and some of them are not. And in the future, you're at museums and some things are fully there and some things are not. Which brings up ethical issues because sometimes the people with these glasses can see things that other people can't and maybe have a leg up. So we'll be talking about that. We'll, for the class, we'll be defining virtual reality. You know, this notion of the arts and art history, science and technology, obviously the human and natural sciences, like how your body moves and how sight is, and cultural, political, all to bring this XR past, present, and future interfold for our class. So obviously, you know, virtual reality has to do with human senses. So in this notion of illusion, looking at a painting, there's illusion. Your imagination that you would have with a book, but also with a video game. Embodiment, this feeling that you're actually, you know, embodied somewhere, and when you move, it's affected. Presence, that you feel that you're really there. Immersion, that it's all around you. All these things come together just normally in your human senses with vision, with addition with smell and touch. And we try to do the same thing with virtual reality, except we're doing it with graphic display devices, body tracking, knowing how your body moves and being able to send that to the computer, and other kinds of motion tracking as well. And that all comes together into a computer system, and then again, it's still your human senses saying, hey, I believe something's going on, this is where I am. So we'll be talking the history of VR, and sure enough, it starts with just art. Obviously, when people would see these big murals and frescoes, they would go, oh my God, I'm transported to this other place. And from computer graphics to video games to XR, we've just moved in that illusion to immersion. We'll talk about VR systems and architecture, how you actually do that, usually with a real-time video game engine. In fact, this class is the major part of it is to make sure you know one of those and you can do it yourself. And we're using the number one real-time game engine called Unity 3D. And hopefully you've already started downloading it and testing it on your computer. We're different this year because you're at home. We can't give you the nice high-end lab that I fought so hard to get for our students at CIAT in Surrey, the 3140 lab that maybe many of you used in 343. So we can't use that. So now we're hoping that you have a reasonable computer at home to do that. So that's why you should register and download Unity and test it and see how well it does on your current system. And then there's I/O devices and software and the tasks that you do. It's all part of this continuum. Obviously, there's the real environment on one side, totally real, and on the other side is virtual environment, which is, you know, in some ways totally fake, and then everything in between, and you can see where augmented reality falls in this. So, and then mixed reality is a little bit of all of it. So I'm going to stop and show you a video to get you better understanding this VR, AR, and MR, and some of the future. Now I'll be leaving these slides around, so there's many other videos that I have here that you can click on. So let's start that.
Most science fiction movies portray the lives of people living in the future with fancy gadgets and equipment, fulfilling all of our needs by command. Perhaps the first technology to mimic such a scenario and make us feel like we are living in the future is going to be the use of XR, or extended reality. So, what is exactly XR? To better understand the prospects of extended reality and its applications, we first need to learn about its constituents. XR encompasses a conglomeration of virtual reality, augmented reality, and mixed reality. First, let's take a look at the most familiar one, VR. Virtual reality is the use of computer technology to create a simulated experience that can be similar to, or completely different from, the real world. Standard virtual reality systems use either VR headsets or multi-projected environments to generate realistic visuals and sounds. The VR headset, with its user interface, offers you a digital experience that you can immerse yourself in any created 3D environment instead of just watching on a conventional 2D computer screen. Some early prototypes of virtual experiences predate even digital computing. Morton Helling wrote in the 1950s of an experience theatre that could encompass all the senses in an effective manner, drawing the viewer into the on-screen activity. In 1962, he built a prototype of his vision called Sensorama, along with 5 short films to be displayed in it while engaging multiple senses such as sight, sound, smell, and touch. Today, there are countless companies producing VR headsets. Among the most popular ones are Sony's PSVR, the standalone Oculus Quest, Valve Index, HTC Vive, etc. Obviously, gaming is the major industry propelling VR forward, but there are other fields beginning to incorporate virtual reality, such as education, medical training, and healthcare in general, the military, etc. If you want to learn more about this subject, we've uploaded a previous video solely dedicated to VR that's been suggested to you at the top right-hand corner. But next is augmented reality. In contrast to virtual reality, AR is an interactive experience of a real-world environment where the objects that reside in the real world are enhanced by computer-generated perceptual information across multiple, if not all, sensory modulates. AR can be defined as a system that fulfills 3 basic features: a combination of the real and virtual world, a real-time interaction, and accurate 3D registration of virtual and real objects.
Often done on your phone or your tablet.
The overlaid sensory information can be constructive, additive to the natural environment, or it can be destructive, meaning the natural environment is masked to show virtual objects. In this way, augmented reality alters the perception of the real world, whereas VR completely replaces the user's real-world environment, the simulated one. There are many camera-based AR apps you can use with your smartphone right now. If you happen to own an iPhone, you can download the Measure app from the App Store for free. This app enables you to quickly measure the size of real objects, a person's height, and it can automatically provide the dimensions of rectangular ones. IKEA also came up with an AR app called IKEA Place, which lets you place virtual furniture in your house by simply taking a photograph of your physical space. Perhaps one of the best free AR apps out there is JigSpace. This app allows you to explore interactive 3D objects of just about anything. The library includes a mixture of fields such as machines, science, how-to, space, and even history. If you want a more in-depth video about this topic, check out our video about AR on your top right-hand corner. And finally, the last in our short list is mixed reality. MR is the merging of real and virtual worlds to produce new environments and visualizations, where physical and digital objects coexist and interact in real time. As the name implies, mixed reality is the mixing of the real and virtual world.
So, in a second I'll talk about the course mechanics, but I'll just say to do any of these things you need a real-time engine. So we will be spending a lot of time talking about different real-time engines, although most of the class is actually using a real-time engine. And in fact, we're trying to make you somewhat quite strong in Unity 3D game engine. And we noticed from the polls, and it's unfortunate it's not being taught in the 200 and 300 classes as much, that many of you haven't done that much in Unity 3D. So most of what the lab is and what Alex Kitson, our TA, who's quite an expert in XR, will be doing is really getting you hands-on training in Unity 3D. It's not the only system out there, but it's surely one of the most significant. I'll be bringing guest speakers in this year, so I have people who work at Unity and work at Oculus and then use these systems in business forums, and then even some students from this very class who are now out in industry. So we're bringing talks into our remote class this year. Obviously, this is about replacing your physical senses. So when you move, you feel when you move. When you turn your head, you feel that. That's what we're doing. So how would you do that? Well, we'll talk about all the devices needed. So you can see over here, this is head-mounted displays, and a lot of people think of XR or VR as simply these head-mounted displays. But in fact, you could do it with projection systems and different kinds of glasses and full cave theaters and VR drones and 360-degree, or literally just on your regular screen as well, which I'll show you. But then there's the input devices that have to track your body, that or at least know. So we have the Kinect controller here, and then body tracking systems that might track your eyes and your hands, like the Leap Motion, and onward and onward. So you might want to use some of these in your projects as well. And of course, understanding 3D movement is quite complex. And as you've learned from 343, and we will continue to understand that within the class. Like I said, it's not all about head-mounted displays. There's these full caves that we're seeing here, which is somewhat, several viewed projections, other interactive systems that people use, and that's both tracking you and then these full large displays. On the head-mounted display side, or HMD, well, we started very early on with systems, and then we've moved. This class actually was pre-Oculus, and here was the very first Oculus that was kind of taped, you can see, to a ski goggles. And then for a while we had DK2s in the class, and we finally, here's the DK2, which were quite clumsy and were error prone. And then I have written here ours, the consumer-based Oculus Rift is, we have a few of these. Now, even though I'm talking about these, we don't have enough for every student, so typically you share them between the teams, and that is just not reasonable or safe in this current COVID era. So one of the big things about this remote class that Alex and I had to change, and is spending a lot of time to try and work out for you, is how you could have remote teams where you're not specifically using head-mounted displays. And I know that might be a disappointment, but it's something we have to kind of deal with. We also have HTC Vives, and we also have Quest. So what we plan on doing is getting everyone in the class the ability to use and experience head-mounted displays by taking out a Quest, but we only have 11. So what we're going to do is have everybody in the class take it out for 3 weeks and return it. So we'll have 3 different groups of students doing those 3 weeks, the first 3 weeks. Then it returns for a week, second 3 weeks, then it returns for a week in the third. So everyone can try and experience it. And we have an assignment. Now, some people are not local or can't get to the library, so in that case, you won't be doing that. But you have an assignment we're calling XR analysis, where you would take one of these devices, take it at home out of the library, which means you have to come into the library and be safe and take it out, and then use it for 3 weeks in some game or project, not one that you've made, just looking at other people's, and then write that up. Now, again, not everybody wants to do that, and that's fine. If you don't, then you would just write up about some technology that you're happy with or things. So let's go on and talk about these things. So again, we had the Oculus and the Vive, which had, you could see these little dots or bubbles on these devices. That's what the tracker pickups, and the tracker's on the bottom here. So this is what we call external tracking. So here you have the headset, these external trackers that you would put on tripods are on the wall, and you place them diagonally in this kind of 10 by 10 or 15 by 15 foot area. So this is how you would do it. Notice you can see the two trackers are here, and then you would be in this space. And then what those trackers are doing is they're able to depth sense your head, therefore how your head moves, and your hands with the controllers, therefore how your hands and controllers moving. Without that, it would not know how you're moving. So we call this external tracking, and surely people are still using that today. And I was just using it yesterday for this classroom tool that I can show you that Jeremy, my PhD, was using. So that's a bit of a setup. All that needs to be set up, and this has been the issue with head-mounted displays. It's this big area that you need in the tracking and how it doesn't always work and such. But with it, you could do these amazing things, like you could draw sculptures in space and play video games and do exercise work and feel that you're really moving in 3 dimensions. We were able to change that a little bit from these early systems to these mobile ones. So if you notice, this is the Oculus Go, was just discontinued. I have one at home. It's still quite good. And it's not tethered, so you don't need a full computer. It pretty much has something like the technology that would be in your phone right in the head-mounted display. And this one did very simple tracking. It really wasn't tracking you in a big way. And they just upgraded it for HTC Vive, the Cosmos, or for Oculus, the Quest. And the Quest is now very popular. It's getting what the original Quest Rift gave you, the Oculus Rift gave you, but now where you can do everything without a computer. So you have these 2 controllers, and now you don't need the room size at all. It's in some ways not as good, but it's still quite significant. So we call this internal tracking, that the tracking is coming because there's cameras. There's 5 cameras. I think maybe I show it a little bit better. I don't. Here, let me just see. No, I don't. Where there's cameras coming out of here that's trying to track the world around you, and therefore your head and your controllers. And again, more and more, we're trying to do it where you won't even use controllers, that you use just your hands. So that gives you a sense now of VR, AR, and MR, and especially the head-mounted displays. Again, as we move into AR and MR, AR you can do with just your phone, and I would demo that. And AR is really looking like the dominant one. It's surely the direction that Apple is moving in. So you would go down, Water Street or Granville Island, and simply either through AR glasses, but these days by holding your phone up, you would know the ratings of the restaurants in the area, and you might have a little character next to you telling you what's a good place to eat, and on and on. And we saw those other examples of AR by holding your phone. And in my research lab and Alex RTA, we're doing a lot with AR as well too. So also there's these hand-body tracking, because it has to track your hands and your body and your face. And sometimes you want more than just the controller. So the Leap Motion is one, and I have some videos here you could look at some point. I do a lot with the Leap Motion, and I actually think it's quite amazing because you do full hand tracking, meaning your fingers and how they move. There's data gloves. There's this treadmill, so you could feel like you're moving in infinitely distance rather than caught in a small space, and other tools. And then on the controller side, well, there are, like I just said, there's hands versus a controller. There's reasons why controllers are very good. They're fast. They're kind of a condensing of your mind into what you want to do by pushing buttons. So people use both. And then there's past that. There's actually, if it's all about your body, some of it is also understanding your body. So this middle one is a mind control system, and we have the Muse system that Alex and I are using. Alex is using it in our PhD, and we have this Empatica watch. That's a $2,000 watch. That's like the Fitbit or the Apple Watch of the future that can tell your heart rate and your breathing. So you could actually build so much more of your immersive experience, because everything about your body can be reflected into the world. There's these application spaces. The video talked about a few of them, but surely scientific visualization, we have a big wall like this as well in the lab. There's architectural walkthroughs. In fact, people are generally buying houses by first walking through them, especially in these remote times. Doing the same thing to historic places, and some of you in your project surely have made a walkthroughs of either places that exist or places that don't with historical sense to them. Virtual surgery, and surely medicine is very big in health, and my lab is very involved with that. And we'll show you some of these therapeutic uses. This is someone with the fear of heights, and you can see how they could be desensitized to that. And we're doing things with virtual avatars, coaches that can talk to people, calm them down, be there for their health issues and such. And of course, games is the big area. And surely a lot of storytelling and narrative. I'll show you some examples of the very first class where we did a very big storytelling situation, and art, and I do a lot of VR art, and I'll bring some of that into the class. So some of that happens in 360 degree, and we'll talk about the difference between 360, which is basically video and capturing video, compared to from 343 what you're more used to, which is making three-dimensional objects out of polygons and curves and things. People are drawing in 3D, which is very big, and there's a nice link here that we could look at. They're sculpting in 3D and VR. The other thing we'll talk about a lot with this class is all this is about fooling your mind. So we'll be talking about perception, cognition, and action in VR, and how that works, and how we're replacing the senses, and how the brain, where the problems are with that. It's still very early on, and why in this class, rather than just being consumers, we want to understand these tools to make better tools of the future. How, especially, there's a huge issues with what how your eyes work, and it's not so much just for your eyes to see kind of these two stereo screens or other ways of seeing XR and VR, because your eyes are not set up for that, and new technologies that are coming out to do that better. And dealing with stereoscopic and depth perception, obviously, there's a big part of approximately 3 to 5% of the population is stereoblind or colorblind, and therefore these techniques don't work. 20% of the population gets sick, nauseous, can't even use it. That's never going to work if this is going to be popular. So how do we understand the mind so we can get past this problems of nausea and not even being able to use these systems? So that's this vision-related sickness, and eye strain, and a number of other things. A lot of the strain and sickness is because your body says something's not right. I see some cues, but not enough, and it's trying to add more and more of the correct cues to make it where people are more comfortable, and that'll be a big part of the class. Now I'm going to go on to the course mechanics. How does this class actually work? In general, I think I'm going to be doing the first class in Zoom, but you see we're going to do things radically different. We're going to use the gaming Discord server, or a server that's mainly used for gaming. That's kind of Slack and text chat and streaming all in one. And then Canvas. So Canvas is where you'll get your syllabus, you'll see your assignments, and where you hand in your assignments. But then we're almost doing nothing else on Canvas, where there's quizzes as well too. And everything else then is on Discord. So Discord is where you would find this lecture, and all lectures where I show up and chat with you all the time, where we have discussions, and I even think they're almost daily. So we'll be pretty async for this class, meaning, a lot of what we'll be doing is jumping onto Discord, and through the many channels, you'll be getting feedback, asking questions, showing what you're interested in, everything. And even our labs will be streamed that way, and surely our communication. So let's go to Canvas, and we'll look through that. And I'll just zoom this up a little bit more. So please get on Canvas and check things out. I'm sorry that it didn't go up as quick as I wanted it to. So we have Alex Kitson is our TA. She's very, very experienced, and we'll talk more about her. So it's great that we have this big VR AR person, and also she's taught a lot too. So the lectures, again, will be like I'm doing now. There'll be videos that I will put up on Discord. The labs will also be on Discord. They will be streamed live, where Alex will be on Unity and you'll be on Unity on your own computer, and then you'll both leave a Discord channel open where you could be asking her questions. So you'll be texting to her, she'll be reading those, and then verbally trying to do things and show you examples. So it's actually really good in that case to have a multi-user, two displays if you have two displays, or your display and which is your laptop, and in fact your phone. So your phone could be on the Discord server. So you have a lot of information, and we have the full Discord up now. So you should register to Discord. Well, I should say the number one thing you should do is register and download Unity and see if it works on your computer. If it's not working on your computer, that's a real issue for this class. You really have to find a different computer if you can, so you're able to actually do Unity in the class. Second one would be to get on to Discord, and then once you're up, we will make you a student, and all of a sudden you'll see everything. So let's just talk about the course itself. So you could see a lot of what we're going to be doing is learning Unity. We're going to be using a lot of different tools. The Lynda tools are excellent. So, and there's ones you could be doing on your own. By the way, there's something called getting a certification in Unity. That certification is what a lot of now companies really like to see. There's a chance you might even want to try during the class, stay ahead of it and actually try and be certified at the same time. Obviously, we're in a remote situation and safety concerns are a big issue, so we can't normally give out these VR headsets. So, and we don't have the lab like we normally do. So we're not going to be using HMD headsets for your final project development. So teams would not be using it because we simply, normally teams would share, and sharing a sweaty headset is just not possible. Still, we would like to get a headset experience to you. We don't have enough to hand them out for each individual. So like it says here, we'll be giving them to you kind of separately for 3 weeks, and you'll write some stuff up on that. So let's look at how the class breaks down. There's these individual lab assignments. So Unity, over from 3 to 8 weeks, you're going to be handing in these assignments that are based on lab and based on Unity. But every day you go to lab, every week you go to lab, we expect you to do a hand-in. So there's these big things that you're shooting for about every 3 weeks, but also every lab we're going to ask to see something. It's almost the way we're doing lab attendance is by you handing in something that you made in that lab, and you can see the hand-in work. There's this big final project, and so you'll be trying to find teams and roles for the teams and coming up with a final project idea. Again, in this case, with remoteness, we have to do it a little bit differently. So AR is pretty good, VR without headsets. But typically you find about 4 people, and all through the year you'll be doing things. You'll see that's worth 30%. These lectures that I'm doing will have, and then there'll be some readings and talks. And within that, I'm going to quiz you about every 3 weeks. So there'll be 3 quizzes. So there's no midterm, no final. I've now changed that. So these quizzes are they just happen, quote, in the beginning of class, which is now remote. They're quick, and they just happen, rather than trying to have to study for the whole half year. They just happen in these 3-week intervals. Participation, well, like I said, there's the lectures will have a weekly hand-in, so that's 5%. There's 5% also for when you take out these headsets and use them for 3 weeks, a 2-page written report. Now, not everyone could have it, so it says, or digging deeper into XR or talking about talks. So that gives you an overview. We've cut it out into the days so you can see, almost instantly is finding teams, using Discord to find teams. You're going to have a very simple lab assignment 1, that basic one due. Your more teamwork in lab assignment is due, and then we'll have a first quiz, more assignments due in lab, then a second quiz. So you'll see it's lab, lecture, team. That's the things that you have to keep worrying about. And then we have our final work. So let me show you the Discord server now that we'll be using a lot. So here I am at week 1, 445. I have a welcome and announcements. Oh, I'm not in 455. That would be the first thing. Here we go. Now we're in 445. So there's a welcome. Alex has already said DM me with your full name and student number. So right now, when you come in, you won't be able to see these things until she registers. I can see we have a whole bunch of people starting to come in, so that's wonderful. I have announcements here, general information to break the ice. I'm explaining who people are and things like that. We have an FAQ. These lectures and videos, so this is where, so you would go to week 1 to find this lecture, and then to talk about it, you would go to lecture. So this is the text area, and this is the weekly video area. So in text, this is where I'll be every lecture ready to talk to you. Assignment feedback, where you could so I should say people in 343 last semester will recognize all this using similar things. Unity help, resources, memes, things about XR, and I've already started populating things with, this is where you could put up videos and we could talk about it. Gaming, what's going on in gaming systems, and I've put up some things there. This is a good place to talk about team forming, industry and careers, what companies are doing. We'll talk about this a lot since we have a lot of people from this class now in industry, and if you're interested in the space getting a job, you'll eventually use this team area for your teams. And then there's this voice chat. So keep in mind there's text channels and voice channels. And voice channels means streaming. So that's video as well as audio. And this is where Alex will be conducting the labs on Friday. So you come in this voice chat. She will be in here on her Unity, and you'll be trying to go along while you're text chatting with her. So that gives you a quick overview of how the class works. Again, we're a bit remote, and the final projects are a bit trickier and different, and how you'll do teaming. We'll spend a little bit more time with that next week discussing that. And let me just go back to PowerPoint. I could tell you I started this class, the very first version of this class was in 2002 when I was at Stanford. So I taught the first VR class at Stanford. You can see we have very simple avatars, and we did this incredible story world where people came into this space. And then when it moved as 445, we were using Adobe Atmosphere, a multi-user world, and we were working and did a big fashion show as one big piece. Now, of course, now typically we would actually be in the lobby for our final projects. And again, we surely are not doing that this year. There's no sharing. Instead, we're going to, of these headsets or even getting together like this. But what I will be bringing in is talking with experts, and with those experts, you're going to learn a lot about VR. So you learn Unity quite significantly in the labs. You're going to learn about XR in a bigger way, not just VR, in the lectures, and we'll be bringing experts into the field for this particular class where they come in through Zoom and other ways. Here's a bit of an example of what we might be able to do. So this is a new multi-user world that I was just in yesterday, and I was just testing out. And let me just show you it for a second. Sorry, I just moved my chair. Hi, I'm Steve DiPaolo, and here I am doing kind of what I normally do, which is teach a class. Boy, what a special kind of class this is. You can see we're in a virtual reality space, and there's a whole bunch of people here with me, so I'm at home on my desktop. Let me just show you what I look like. So I'm going to turn the camera to me. Well, there I am, and you can see I'm lip synced, and I'm doing gesture, and that's all because it's being done through my voice, because I'm just sitting at a desktop. But if I was like Jeremy, who's here, and I came in with a full VR system, well, then my gesture would be controlled by the controllers and stuff. So it's amazing we can do. So I'm in a full classroom here, and you can see there are people sitting. So that's amazing. In fact, in a 3D or VR, the avatar looks like me. I'm just using my voice and getting all that gesture. But if we look at Jeremy, who's over here, he's in a full VR suit. So he's showing how he can move around and talk and everything, because then he could do these things with his hands and things. So I'll have you watch this video from beginning to end. I was thinking of completely teaching the class in World, and all of us will be in here at one point, but this is called Tivoli Cloud, and you might want to download it and try it. It's a very high-end system, and it works with Unity. And some of you, I assume, might be doing your projects in here. It doesn't have to look like a classroom, but it can. I will show you a different system that's also from our lab. So this is AR
Hello.
on a phone.
Hello, friend. I've been waiting for you.
Oh, have you now? What's your name?
I'm Earth Avatar.
Where are you from?
I have been co-created by various experts around Canada.
So same thing, it's doing auto gesturing. This isn't a real person, this is AI, and a script has been written. And the script is helping this woman understand the details of AI and ethics, and we have a grant to do that. We have a similar system to help the elderly. So if some of you might want to do use AR in a way like this. Now the difference between AR and VR and XR, well, if you're doing this avatar, it could be with full glasses, it could be on a projected screen, it could be on a regular monitor, or you could be seeing it through your phone with your desk in the back. It's all the same Unity in a way, it's just how you put it together. So these are some of the possibilities that we could do for the class. So definitely get on Canvas, get Unity downloaded, and log into Discord, and then we'll see you Friday. Thanks very much. Bye.